This chapter is all about circles, and the most important thing to learn a shape is to know the parts of it. So we're going to go over a couple of vocabulary words, and then we're actually going to solve some equations. So the first part of the circle we're going to talk about is the center, and the center is the exact middle of the circle. And how we're going to name that is just by a letter. So you're going to see the circle symbol and then P. So I'm going to be going back and forth to the bottom of the page where you have this circle. Okay, so the center of the circle is the dot, and that is the P. And the circle is at the bottom of your page. So as we go through and draw things, I want you to draw it as well. So the center of the circle is P. Okay, that's the name of the circle. So if I say in circle Y, you're going to go to circle Y, or whatever variable I give you. The next thing is the radius, and the radius is a segment, which means it has a beginning and it has an end. It doesn't continue on forever. It's a segment from the center of the circle to the edge. Okay, and we're going to name this PR. And again, it's a segment, so it's just the line at the top. Now, one thing that is interesting about radii is that from the center to the edge, no matter where you draw it, is going to be the exact same length. So this radius is going to be the same length as this radius, or this radius, or this radius. Any line you draw is going to be the same length, because that center is the exact middle, and this radius is going to come all the way around. Anywhere you draw it will be the exact same length. The next one we're going to talk about is the diameter. The diameter is also a segment, but this goes from one edge of the circle to another edge. One thing about the diameter is it must go through the center. Okay, we're going to name our diameter AB, again with the segment symbol over it. So the diameter goes from one edge through the center, one edge through the center to the other edge. Okay, so it touches one edge to the other. The diameter is actually special as well because it is the only line that will cut that circle directly in half. So any diameter you see, it will cut it in half. A chord is also a segment that goes from one edge to the other. But the difference between a diameter and a chord is that a chord does not go through the center. Okay, it does not go through the center. So we're going to name a chord RT. So let's draw RT. RT. Okay, so notice how it does go from one edge to the other edge, but it does not go through the center of the circle. So that is the difference between a chord and a diameter. A secant is now a line. So a line starts from outside of the circle, goes through the circle, and exits and continues on. Okay, so it's a line that goes through the circle and intersects it twice. Okay, so I'm going to call this AC. Okay, so a secant goes into the circle. I'm going to have it intersect at point A. It's going to go through the circle and exit at point C. So this line opens or starts the circle at A and continues to move out of the circle at point C. So AC is the line that we're going to use. And because it is a line, we have to draw the arrow above it. Secant and tangent are very similar because they're both lines, but this is a line that intersects the circle only once, which is the tangent. Okay, it's a line that intersects the circle only once. So we're going to go a line at T. So this line does not go through the circle, but it only touches the circle at one point. Now we need two letters, so we're going to say T, let's say Q. So our tangent line is TQ because every line is made up of 2 points. Now notice again, tangent does not go through the circle, it just touches the circle, where secant has to go through the circle. The point of tangency is where the tangent line intersects the circle. And that's at point T. Okay, so wherever that tangent line touches the circle, that is called the point of tangency. The semicircle is half of the circle. Now we talked about something cutting the circle directly in half, and that's the diameter. Okay, a minor arc is less than half, and the major arc is more than half. Now when we're naming these, semicircle and major arc have to have 3 points. So the first one I'm going to start with is the minor arc. So the minor arc is less than half. So you go along the outside of the circle and you go from one point to the other. So what I just highlighted is a minor arc, and that would be minor arc AR. Okay, and to denote it that it's an arc, you have to draw the little arc symbol over it. A semicircle is half of the circle. So this AR, excuse me, would be continued all the way around, which would cover half of the circle. Again, semicircle and major arc have to have 3 points. So A, R, B, starting point, somewhere within the middle, and the ending point, A, R, B, with your arc symbol. And a major arc is more than half. Okay, so we would bring this continuing around to another point that would show more than half of the circle. So this would be A, our starting point, somewhere in the middle, let's say T, and our ending point C. And that's how you would name your major arc. So that's your vocabulary. What we're going to do is go on to a little more of these arcs and chords and kind of talk about how they relate to circles. So arcs and chords actually form angles within and radii form angles within the circle. And when you have two radii that form an angle, it's called a central angle. And that's when an angle whose vertex is the center of the circle. Okay, and it forms this minor arc. So this angle here, we're going to say central angle ABC. Okay, ABC, it's your angle. Okay, it has the exact same measure as its minor arc. Okay, so your central angle and your minor arc have the same measure. So if I say this is 60 degrees, angle ABC, the minor arc formed by that angle also has the same measure. So a minor arc has the same measure as its central angle. okay? Now, in a circle, we have 360 degrees, okay? So if our minor arc is 60 degrees, what is left for the major arc CDA, right? CDA. So here's our major arc. To find the major arc measure, you do 360 minus the minor, and that gives you the measure. So what is 360 divided by 6, or minus 60, which would be 300. And one thing to always remember is that semicircle. A semicircle always has a measure of 180 degrees. So we're going to go on, excuse me, and talk about if we have more than one arc. Okay, so if you think back to like chapter 1, we talked about segment addition and angle addition. That same concept is arc addition. So if we had the center point here and we were to connect all of our radii that are the same length, the big arc FR, okay, is formed by the measure of arc FO and the measure of arc OR. So the two small arcs create the big arc. So that concept is going to be what we're going to use in the following problems. So here, given that measure FJG is 20 degrees, I know it's not on here, but what is the measure of FG? Since its central angle, or the angle has their vertex at the center, it's a central angle, that arc is also 20 degrees. Okay, and I'm also going to give you that FK is 35 degrees. So segment addition, if the whole is 35 and I've used 20, GK has to have a measure of 15. So the measure of GK is 15 degrees. Now I want to know the measure of KHF. The measure of KHF, you would then take 360, right, because it's the major arc, and minus that small arc that we've had. Now that 360 minus 35 is 325 degrees. So the measure of KHF, the major arc, is 325 degrees. So always remember that you can do segment addition to find missing pieces, and you have this major arc that you can subtract from 360. The last one, sorry I'm rushing, but I'm running out of time, I have 2 minutes. Here we're going to try this one. CD has a measure of 3x, so now we're adding in a variable. DA has a measure of x plus 80, and AB has a measure of 5x minus 2. Now we cannot add all these up and set them equal to 360 because we are missing one piece, but we have a diameter. And remember what I told you about a diameter is that's the only piece that can cut it in half. And we said that a semicircle, okay, half of a circle, is 180 degrees. So we have two measurements that we can add together and set equal to 180. So if we add, we have 4x plus 80 equals 180. Subtract 80. So you get 4x equals 100, or x equals 25. Okay, so what we're going to have to do is substitute this 25 into all of what we have. So 5x minus 2 is 123, after we know x is 25, and 25 plus 80 is 105. Okay, and that is angle DAB, DAB. Okay, and because we know those two measurements, we are allowed to add them together. So 123 plus 105 is 228. Okay, now we also know this is 75. So two ways you could find BC is do 360 degrees minus 75, 105, and 123. Or you can use that semicircle concept again and do 180 minus 123. Either way, that angle BC is 57. So, finishing up, your homework is number 1 through 17 in your packet. Please try those. The answers are online, and good luck.